All right, guys, I'm going to make this super quick, geometry students. So here we go. A couple theorems and some definitions. Central angle of a circle is an angle whose vertex is the center of the circle. Makes sense, right? So angle ACB is a central angle of circle with center C. If the measure of angle ACB is less than 180 degrees, then the points on the circle that lie on the interior of the angle form a minor arc. That's just a name we give to this arc. Everything else over here is called a major arc. And then if we had a point here, call it E, where we knew EB was a diameter, we would call arc BAE a semicircle. That's an arc with endpoints on a diameter. Again, looking at some more definitions here, the way we name arcs. Minor arcs have 2 letters. And anything that is 180, a semicircle or greater, takes 3 letters. If I put a point here, E, arc A, EB is the same arc, so not even congruent, it's the same arc as arc ADB. But arc E, let's say this, arc EBA is completely different than these because it would start at E, go in the direction of B, and end at A. The third letter, the one in the middle, is associated with direction. So what direction do you go from E to get to A? If I said arc EA, then we would assume it's this one here that is a minor arc between the two. All right, so other things moving along. How do we measure an arc? You will hear me say this 100 times. The measure of an arc is the measure of its central angle. The measure of an arc is the measure of its central angle. The major arc has a minor arc associated with it, and the measure of the major arc is 360 minus the measure of the minor arc. So in this case, if we know the measure of arc AB is 50 degrees, then the measure of arc ADB is 310 degrees. If you have concentric circles, circles with the same center, well, all 3 arcs here have the same central angle, so the measure of all of these arcs are the same. The lengths are different, but we're not talking about lengths right now, we're talking about measures. Other things that we need to know is 2 arcs can be adjacent. That just means that they're next to each other. And then we have this little arc addition postulate. It's just like segments. We can say that measure of arc AB plus the measure of arc BC is the measure of arc ABC. Just a postulate for the way arcs work. Other things we can talk about. Congruent circles have the same radii. Congruent arcs have the same measure. All right. All of that seems pretty straightforward, but it's all one section of your book. So I can't overstate the importance of this concept, that the measure of an arc is the measure of the central angle. Look through all of these things again. Notice there's no theorems, just one postulate for how arcs work. Everything else we're talking about measures. We're going to do 2 units because we're getting close to the end of the year. So remember that a chord is a segment with endpoints on the circle. When we have a chord in a circle, it divides it into 2 arcs. If that chord is the diameter, we get 2 different semicircles. Any other chord, there's a minor arc and a major arc. If you have 2 congruent chords, then you have 2 congruent arcs. This is an if and only if theorem. So if you know 2 arcs have the same measure, that means they're congruent. If 2 arcs are congruent, then the corresponding chords are congruent. If 2 chords are congruent, then the corresponding arcs are congruent. Some other interesting theorems we can prove with chords. A chord is if one chord is perpendicular to another, then the chord let's see, if one chord is perpendicular bisector of another chord, then that chord must be the diameter. So that one's kind of interesting. The other one says, if a diameter of a circle is perpendicular to a chord, then it bisects that arc, and then it bisects that chord. So these are kind of related about how chords work, that any diameter drawn perpendicular to a chord will bisect it. It's not too hard to prove that because you end up getting some right triangles with a hypotenuse leg situation with the shared leg. Over here, you've got the radii with congruent hypotenuses. Yeah. And then the other thing is that if we have two chords that are congruent, we know they're the same distance from the center, and that's again an if and only if. Guys, that's it. That's the whole two sections. That's why we're trying to do two so quickly in this video. If I were you, I'd watch this video again, write down all the theorems. They all make sense. I will ask you to prove them in class. All right, have a good night. Peace.